It would take one machine 4 hours to complete a large production order and another machine 3 hours to complete the same order. How many hours would it take both machines, working simultaneously at their respective constant rates, to complete the order? It's a very typical rate problems, and in summary, machine A can do something in 4 hours all by itself. Machine B can do something in 3 hours, do the same task or complete the same task all by itself in 3 hours. How long would it take both machines to complete the job if they're working together? Um, it's a very practical, real world problem. We're going to use algebra to solve it. And in order to really understand the solution, we have to understand each step, why each step works. If we don't understand that, we won't be able to solve problems that look different from this. So I'm going to paraphrase the question. The first machine can do the job all by itself in 4 hours, and the second machine can do the same job all by itself in 3 hours. How long would it take both machines to finish the task if they're working at their own constant rates, of course? Alright, so let's look at our solution. Okay, recall from our question, the first machine takes 4 hours to complete the task. Let's assume this is our task. Okay, if the first machine takes 4 hours to do the whole thing, in 1 hour it'll do only 1/4. 1 hour is kind of important because we are finding a rate instead of defining rate and all that. Let's just try to understand that if something can be done completed in 4 hours, in 1 hour only 1/4 is completed. So if the first machine takes 4 hours to do the whole thing, 1, 2, 3, 4, in 1 hour it'll do only this much, which is 1/4 of the task. Okay. In a similar manner, we can say something like this about the second machine. Recall, the second machine takes 3 hours, 1 hour, 2 hours, 3 hours to complete the task. In 1 hour, it'll do only 1/3. The second machine in 1 hour will do 1/3 of the task. The first machine in 1 hour will do 1/4 of the task. Now, again, let's go back and combine the two now. Now recall, now the two machines are working simultaneously. In the same 1 hour, machine 1 will do 1/4, and during the same 1 hour, it's not taking machine 2 or the second machine an additional hour. In the same 1 hour, machine 2 will do 1/3 of the job. So from here we can conclude that machine 1 will do this much in 1 hour, machine 2 will do this much in the same 1 hour. So in other words, in 1 hour, the two machines together will do this much, which is 1/4 plus 1/3. So in the same 1 hour, machine 1 and machine 2 will do 1/4 plus 1/3 of the task. If we use our knowledge of addition of fractions, let's erase the little highlights so that we can read the text. So we concluded that in 1 hour, the two machines will do 7/12 of the job. We really have to get what's going on here, how we got to 7/12 and how the two machines will do 7/12 of the task in 1 hour. Now, we are supposed to find how long would it take the two machines working simultaneously to finish the job. So we are going to introduce a variable. Let's erase the highlight. Let's say this is what we're looking for. Suppose the two machines working together or simultaneously take X hours to complete the job. This is what we're looking for, X. How long does it take the two machines working simultaneously to finish the job? We're going to call that time X. So let's say it takes X hours for the two machines to wrap up the job when they're working together. Okay, now here is it's a difficult concept, but we'll have to get it. Let's see what we mean by this. Now, Remember, we were doing if a machine can do something in 4 hours, in 1 hour it does 1 over 4. If a machine can do something in 3 hours, in 1 hour it does 1 over 3. We are using the same concept. The only difference is the two machines are now kind of becoming a system of machines. We can pretend as if they are one single system. So if it takes 1 hour, sorry, if it takes X hours to do the whole thing, in 1 hour the two machines will do only this much. So let's go over it once again. Let's erase all the highlights. All right. In summary, the two machines takes X hours to do the whole task. In 1 hour, it'll do 1 over X parts of the entire task. Now, recall from the previous slide, we concluded that the two machines can do 7/12 of the task in 1 hour. And now here we are concluding that the two machines can do 1 over X parts of the job in 1 hour. So they have to be equal. Okay, so what we're doing here, this 1 over X comes from here. The two machines do this much in 1 hour. And this comes from the previous slide where we concluded that the two machines can do 7/12 in 1 hour. So they have to be equal. Now if that's the case, all we need to do, let's erase the highlights, all we need to do is solve this equation for x. 1 over x is equal to 7 over 12, which is not terribly difficult to solve. X is not 0, so we can kind of flip it. The left hand side is x over 1 and the right hand side is 12 over 7. So basically x turns out to be 12 over 7, and if you convert it, you're going to get 1 and 5/7 of an hour. So basically my answer is 1 and 5/7 hours. So the two machines will take 1 and 5/7 of an hour to do the whole job. And we really have to understand each step if we want to understand the whole thing. That's my answer.